Alright, so for SSA angles, that is side-side angle. Well, so we're gonna have pretty much three different situations. So one situation in which, well, given the data, we're not gonna have a triangle at all. We're gonna have a situation in which only one triangle um, will be in the picture, or the third situation in which we have two triangles. This is also called as the ambiguous case. All right, so let's see. Let's have a look at this one. Let's solve the triangle. See, okay, let's label A, B, C for the sides. A, B, C for the angles. 50 degrees for the angle. Side C is 1 and side A is 2. Alright, so what are we going to do in this case? Well, so in this case, so we have all the information for C and one part of the information for A. So what we're going to do is relate C with A using this law of sine. So sine A divided by side A equals to sine of angle C divided by side C. Substituting the numbers, sine of 50, no, sine of A actually, over A, which is 2, equals sine of 50 degrees over 1. So sine A equals to sine 50 degrees. And well, sine of A equals sine, let's use the graphing calculator for this, to sine 50. That's 1.53. We get 1.53. But look at this. Well, actually, by the way, before moving on, solving SSA angles involves solving trig equations. And in this case, we need to consider all the possible solutions in the Cartesian plane. Well, so let's say 1.53. Well, then A equals inverse sine of 1.53. And in this case, we're going to have a no solution. Why? Well, because if you consider the domain of the inverse sine, so that's a second inverse sine of 1.53. The domain of inverse sine, it goes from -1 to 1. And look at this when we do that calculation. So that's a no solution. So in this case, solving the equation gives us a no solution. That means no triangle. What about the situation in which we have one triangle? Well, first of all, let's see. Side A, side B, side C. Angle A, angle B, angle C. What are we given? Well, we're given angle A, which is 40 degrees, side A, which is 3, side B, which is 2, side C, which we don't know. Alright, so in this case, what we're going to do is we are going to relate A with B using the law of sines. Look what's going to happen in this case as opposed to the previous examples. So sine angle A divided by side A equals to sine angle B over side B. Alright, so let's see. Let's substitute the numbers. Sine 40 degrees over 3 equals sine B over side B, which is 2. So solving for sine B, we are going to get to sine 40 degrees over 3. And in this case, okay, let's simplify this. Second quit to sine 40 degrees over 3. And that's going to give us 0.43. Let's round up to 0.43. 0.43. And B will therefore be sine inverse of 0.43. Well, using the graphing calculator, this is the real trick. Second inverse sine of 0.43. That's going to give us only one value, the one value of 25.4. Let's round it to. But there's something that we need to keep in mind. One thing that we need to keep in mind is that sine is positive in two quadrants. So there's two angles that have a sine of 0.43. Number one is 25.4, and the other one is the other angle by subtracting from what is this, minus minus 180 degrees, well, 154 degrees. So that's actually over here. All right, 154.5 degrees. So there's two solutions that we need to consider when it comes to this type of equations. 154.5. However, one of them will be ruled out. Which one? This one, I'm going to rule it out. And the reason for this is because when I add A plus, okay, let me call this B1 and B2. A plus B1 equals, so A equals 40 plus 25.4. Actually degrees, don't forget the symbol. And in this case, that's going to be where's my, what I have down in my notes? 40 plus 25.4. That's going to give me 65.4, which is fine. I'll tell you why in a minute. But in this case, A plus B2, in this case, well, that's going to be 40 degrees plus 154.5 154.5, and if you notice, it's going to give me 194 degrees. Well, this is bigger than 180 degrees, and this is combining only two angles. So that's why we need to get rid of this potential solution. So that's why in this case we are not getting two triangles but only one triangle. So in this case the angle 25.4, and actually let me put it at 25.4. That was angle B. 25.4. When you look at the other one, this is going to make more sense when we look at the other case. So now that we have 25.4 plus 40, we can combine those two. Well, 40 plus, or actually 180 minus 40 minus 25.4. 114.6 is the remaining angle. So now we can use the law of sines again to find the missing side, which in this case is sine B over side B, or equals to sine of angle C divided by side C, which is to be determined. So let's see, sine of B, which is 25.4 over side B, which is 2, equals sine C, which is sine 114.6 over unknown. So C equals to cross multiply 2 times sine 114.6 over sine 25.4. And this is going to be roughly, well, let's use the calculator for this. That's a 2 sine 114.6 and then divided by sine 25.4. So that's for 4.23, 4.24 roughly. Okay, so 4.24. Of course, we could have used A and C instead of B and C, but this time I decided to combine B and C. If you do A with C, you should get the same. Okay, let's look at the last example for this section. So let's make a list. A, side B, side C. Angle A, angle B, angle C. All right. From here, in this case, we're going to break it up into two separate angles, two separate situations. All right. So you'll see why is this going to happen. So A, which is 6, B, which is 8, and C, which is unknown. Angle A is 35 degrees. Angles B and C are unknown. All right. So let's use the law of sines to put together A and B. So sine of A, that's a sine 35 over 6 equals sine of angle B, which is to be determined, and in this case divided by side B, which is 8. Okay, so let's solve. So sine B equals 8 sine 35 degrees over 6. Sine of B will be then, okay, let's use the graphing calculator for this, 8 sine 35 over 6, and I'm going to get 0.76. 0.76. When we solve this equation for B, that's inverse sine of 0.76. All right. Which in this case, well, there's two angles whose sine is 0.76. So in this case, that's going to be, on the one hand, inverse sine 0.76, 49.5. All right, 49.5. That's going to be 1. All right, 49 point. Well, for some reason I got different. Oh, never mind. And by the rotation, the other potential angle, so 180 minus this, that's going to be 130.5. All right. So there's two potential angles here. All right, so let's test whether adding B with A, each of the B's with A are still going to be under 180 degrees. If it is, then we have two angles. Otherwise, just like in the previous example in which it failed because it got over 180, then that would be two angles. So in this case, A plus, that's a B1, B2. A plus B1 equals 49.5 plus 35, which equals, let's see, 49.5 plus 35. That's 84.5. So we're good in this case because this angle is under, it's under 180 degrees. It's not going past. Now let's A plus B2, which is B2 130.5 plus 35, and then in this case it's 100 and what do we have? 130.5 plus, in this case, 35. That's 165.5, and in both cases we have the addition to be a number less than what's this called? Less than 180 degrees. So that means there's room for a third angle. All right. So in this case we need to redefine this setup into 2. Okay, so I'm gonna do A equals to 6, B equals to 8, and that's gonna be for do we need, okay, B equals to 8 and C1. Why C1? Well, you'll see. A equals 35, big B1, all right, big B1, which is 84.5, and no, not 84.5, it's 49.5, and C1, which is to be determined. All right, so C1 is to be determined. Well, we can do it from the difference between 180, and then the other situation, the second triangle, A equals to 6, B equals to 8, C2 equals something, whatever we need, whatever we figure that out. A equals 35, B2, which is 130.5. And in this case, let's see, C2, which we will figure out. So let's figure out the angles, and then I'll give you the picture actually for this. So 35, okay, 35 plus 49, okay, it's 184. Oh, I got it already. Got this already. 84.5 and 165.5. So the picture for this, one of this is an obtuse angle, the other one is an acute angle. All right, wait. No, there's something wrong over here. Nope. Give me 1 second. There's something wrong over here. I needed to subtract those numbers from 180. So 180 minus 180 minus 49.5 minus 35. And that's 95.5. And on the other hand, 180 minus 130.5 minus 35, I get 14.5 degrees. All right, so we need to solve, we need to use the law of sines to find C1 and C2. On the first situation, the picture for this, well, it's a triangle like this, and on the other hand we have a situation that looks like this. There's an obtuse angle, the 130 degrees, the 14.5, and the 35 degree. And then we have the 35 degree. Where's my other 35 degree? In this case, that's 95.5. Okay, let's just give the pictures like this. So let's sine angle B over side B equals to sine angle C1 over C1. And then the same over here. But for 2. So sine B actually involves B1, B2. So sine 49.5 over 8 equals sine C1, which is 95.5 over C1 to be determined. And over here, sine B2, which is 130.5 over 8 equals sine C2, which is 14.5 over C2, which is to be determined. So C2 will be ultimately 8 sine 95.5 over sine 49.5, which will be approximately, and then C2 will be 8 sine 14.5 over sine 130.5. C2 approximately. Okay, let's do these calculations. 8 sine 95.5, close parentheses, be sure to close parentheses, and then sine 49.5. So that's a 10.47. And that's 8 sine 14.5 over sine 130.5. And that's 2.63. Okay, so what's the overall picture? I know this example, it's not my favorite example. It's a little bit confusing, but what we have here is a triangle like this. A triangle like that became something like this, in which this side is exactly the same as that side. This is A6, 6, and then this is the obtuse angle, the 130.5, or yeah, the 130.5, and this is the 14, where is it? No, not the 14, oh yeah, that's the 14.5. You know, this big angle became split into these two situations. So that's the overall picture. You know, when there's two angles that add up to less than 180 degrees, we get actually two triangles that we need to solve, and in this case those are the ones. Alright, so this is the end of this section. I'll see you in the next video.